Hello everybody. Today we're going to be talking about section 11.3, which is on radio communication. One of the most kind of important applications of electromagnetic radiation. Radio communication used to be one of our only ways to communicate, and it's still used quite a bit. We don't use it in the same way we used to, but it has to do with how we use satellites and other information technologies, including your cell phone. So just a quick review. Radio waves are the lowest part of the electromagnetic spectrum. When I say lowest, they are on the far end on this side. They have the largest wavelength and the lowest frequency of any of the electromagnetic waves. So, how exactly does radio communication work? Well, when you tune into a particular radio station or a satellite transmits a signal, it uses what's called a carrier wave. So a carrier wave is a EM wave with a specific frequency. So that frequency is indicated when you talk about an AM radio station, for instance. If it's AM 1500, that specifies the frequency of that carrier wave. Now, you can't just send a wave. You have to change that wave in some way to carry the information. If it was just one wave, you would perceive the song you're listening to the radio as just one sound. So somehow they have to encode all that information, all the music, all the sound into the wave so that your radio can understand that and then give it back to you in the proper form. To do that, they use something called modulation. So this is adding a signal to a carrier wave. So there are two ways to produce the signal on the wave, and that's by modulating either amplitude, which is what AM stands for, amplitude modulation, or messing with the frequency, which is called frequency modulation. So if we had a wave, let's say the wave looked like this, they might code information in that wave by changing the amplitude to certain parts. Maybe it goes up really high, down really low, then up a little bit, down a little bit, and they can use that to encode the information in the carrier wave. That would be an example of amplitude modulation. If they want to do frequency modulation, they're going to create areas where the wave is got a tighter frequency, and then maybe goes back to the normal frequency, and then tighter frequency again, then goes back to the normal frequency. Now, these variations in frequency are very, very small compared to the size of the carrier wave, because if you change the frequency too much, you'd be at a different carrier wave. So they have to mess with the frequency very small amounts in order to modulate it in a way that it can be understood without mixing with another signal. And you can have situations in which you pick up two different carrier waves at the same time. If you've ever been driving and a radio station starts to overlap or mix in with another radio station, which happens on occasion, usually with FM stations, that is an example of your radio in your car processing two different carrier waves. Now, the process of communicating with these. So broadcasting is the term we use for sending out the waves. To broadcast a wave, you use an antenna. And what you're doing is you're creating an electromagnetic wave, a radio wave, by using electric current to move electrons. And the movement of those electrons in a conductive material like an antenna creates the EM wave. Now, when you want to receive a wave, you need a device that's set up to do so. You need a device that's going to react to an EM wave. So it's going to take the EM wave that hits it, and you'll have a tuner. If you remember, if you've ever played with a car stereo that has an old school tuner, you spin this and it changes the station. And the reason why it does that is it changes the frequency that the receiver will respond to. So by changing that dial, you change which frequency of electromagnetic waves that your receiver will respond to. So it takes that EM wave and it has a method of decoding it. The EM wave goes through a process where it is read, and it's not literally read like something sitting there reading it like a computer. It is, it goes through a filter that can pick out the distinctions in the wave and tell what sounds or signals are supposed to get out. So then we have some form of output signal. Whether that output signal is in the form of light, sound, or something else, that's how the broadcasting and receiving of waves work. Now there's two kinds of signals, both in terms of what we talk about broadcasting and receiving. There are analog signals. Now, these signals change smoothly over time. So an analog signal might look like this. Smooth, smooth, smooth. And it changes, but it changes smoothly over time. As opposed to digital signals, which are either on or off. So a digital signal might look like this. On, off, off, on, off. And that's an example of a digital signal. Now, analog signals are what we originally started using when we started broadcasting radio signals. And television used to work off a similar thing. But since then, almost everything we use has been switched to a digital signal because it's easier to work with in terms of computers. So computerizing the process of signal sending and signal receiving made us transition from analog signals to digital signals. So when we do this, when you have a lot of devices, aren't just about sending and receiving. For instance, a phone is a transceiver. That means it can send and receive EM signals, radio waves. So your phone can send and receive because it can send, and it can do both simultaneously, because it can send your voice and let you listen to someone else's at the same time. So that allows it to have both the sending and receiving capability at the same time. So cell phones are a big example of a radio wave. We use radio waves to communicate through cell phones. The reason why you get breakup or bad signal or dropped calls sometimes is because your transmission is blocked. If you've ever had your cell phone go out inside a building or inside a tunnel in a car, that's because the radio waves from your phone can't get to their destination. Satellites also use radio waves to communicate. In fact, we use satellites with our cell phone technology. So the basic idea is that you have your phone and it's sending out signals, and it's going to hit like maybe a cell phone tower, which is just a large antenna. That's going to receive the signals. That can send signals if it needs to a satellite in space. That'll then send those signals to another tower, which will then send them to your friend's phone. Now, there are times where this process can be circumvented. Walkie-talkies, for instance, allow you to, or walkie-talkie mode on a phone, which some phones have, allow you to do the talking from here to here without it ever going through the process of the cell phone tower. Sometimes a tower can send it directly to a cell phone if the other cell phone is within tower range. But let's say you go to an area where there is no tower, you might not have the strength to get your cell phone signal out. So a lot of the difficulties people have with cell phones, especially in buildings, are because the electromagnetic waves can't get through. Another thing that's connected to your cell phone is a GPS, or global positioning system. This is part of what you use when you do Google Maps or anything like that to find your way using your cell phone. A global positioning system is a system of satellites in space, ground stations, and devices that monitor a device's position. So one of the things you can do is, if you're ever on Google Maps, one of the things it can do is it has recorded data. It knows where you are. And let's say you are hungry and you're on the road, you can click on a little button on your Google Maps that says food near me. And when that happens, it pulls up places, restaurants, so that you can see them. Now, the locations of those restaurants have all been programmed into the algorithm. The Google knows where those are at all times, and it can monitor your position. It knows you're here, and it'll be like, okay, well, I'll start giving any places close to that position, but it has to know your position to do so. So all of these things that we use in our everyday life have to do with EM signals and radio waves for communication. All right, that's it for this time, guys. We're going to be preparing for the quiz on electromagnetic radiation here coming up. So stay tuned. See you next time.